Hello, Algebra 2 small group. I am having to cancel class on Wednesday and Thursday this week because I'm giving in-person ACT testing. So this is to replace Thursday's Algebra 2 small group. And it is a lesson on 6.08. I realize this was a lesson from last week, but it's a really, really important lesson. It has a quiz with it and a lot of things that come after 608 in Unit 6 are going to rely on your knowledge from 608 normal distribution. So I'm going to go ahead and get started. This is the week's announcement: 610, 611, 612, 613, 614. All juniors have in-person testing this week. And again, I will be out testing Wednesday and Thursday. So I've already sent an email with the lesson from Wednesday, which is 6.13, and then I will be sending your small group lesson for Thursday once I record this lesson. Just a quick reminder that on Friday, this Friday right here, which is March the 14th, that is the end of quarter 3. That'll be the last assignment in quarter 3. Alva gives you 7 extra days to finish quarter assignments, and so your assignments will actually close on Friday, March the 21st. So this is when they'll close, and you won't be able to get to anything from Unit 1 all the way up to this assignment. Come Monday, which will be 14th, 15th, 16th, March the 17th, and that'll be assignment 6.15. That'll be a unit test, part 1 and part 2. You will have the part 2 part. This will begin quarter 4. So once you get to 6:15, that's quarter 4, and they'll have a different ending date. But this Friday, March the 14th, is the end of quarter 3. You have a 7-day extension, and then all of your assignments will close on March the 21st. If you have any questions about that, definitely let me know. Okay, let's take a look at the normal distribution curve. Normal distribution curves can be symmetric, so we'll look at some that are symmetric, and we will look at some that are skewed left, and we will look at some that are skewed right. Most of the ones, almost all of the ones that we will study in section 6.08 are going to be symmetric. When you have a normal distribution curve that is symmetric, the mean will be right in the middle. So it'll be the middle point on the x-axis. Your mean and your mode and your median are all measures of central tendency, but we're not going to even be getting information about the mode and the median. We're mostly going to stick with mean. The left-hand side of your graph is going to look exactly like the right-hand side of your graph. If your function is skewed left, then again, let's find the median. Here's the median. the mean, my bad. The mean is the average. Here's the mean. And remember, the mean is usually right on top of that mountain. So if the mean is if your mean is to the left of where the mean usually is, so arrow pointing to the left, then they say that this data is skewed left. In the next example, the mean is here, and that mountaintop, if we think about where the mean is supposed to be, your mean is to the right. So that would be skewed right. The mean is usually on top of the mountaintop. So if the mean is to the left of the mountaintop, the data is considered skewed left. If the mean is to the right of the mountaintop, the data is known to be skewed right. We do have this really good slide here. Type this up. Actually, I probably didn't type it up. This is too neat. I don't think I would have been able to do this. Probably stole it from the internet somewhere. Here is vocabulary for normal distributions. Number 1 says maximum value of the curve occurs at the mean. And then we use this symbol. So this is the mu. It's pronounced mu. Kind kind of looks like a cursive U, but it stands for mean. And again, your mean is going to be right in the middle of your x-axis, and you could also think about it being on top of that mountain. The standard deviation, that's going to be, this will be 1 standard deviation, this will be 2 standard deviations, this will be 3 standard deviations. They use the symbol sigma, if I can talk today, and that will stand for standard deviations. Number 3 says nearly all of the data under the curve represents about 99.7% between standard deviations of 3. So this would be -3, this would be +3. So if we take all the area that's shaded underneath that curve, it's about 99.7%. There's a little bit on the right tail and a little bit on the left tail. That would make it a total 100%, but we mostly just deal from -3 standard deviations to +3 standard deviations. Number 4 repeats what I just said. The total area under the curve is 1 or 100%. And that would be if you were looking at the whole entire curve. And number 5 says the area under the curve between two x values corresponds with the x probability. And we'll be looking at the area under the curve, and we'll be talking about that as probability. I have about 4 examples for you. Number 1 says, suppose the length of an oarfish. So I'd never seen an oarfish before, so I Googled oarfish, and I put a picture of it in the top left corner of your screen to get an idea of what it looked like. It is normally distributed. The length of this oarfish is normally distributed along a standard bell curve. Oh, by the way, this graph could also be called a bell curve. It's kind of a slang term. So normal distribution or bell curve. And the mean is 6.5 and the standard deviation is 1.5. Both of these are meters. So mean is 6.5, standard deviation 1.5. What I usually like to do is I like to go straight to my graph. At 0, these are going to be z-scores. At 0, you're going to put your average. So we'll do 6.5. As we move to the right, we will add. We're always adding when we move to the right. As we move to the right, we'll add our standard deviation of 1.5. So 6.5 plus 1.5 will give me 8. 8 plus 1.5 will give me 9.5. 9.5 plus 1.5 will give me 11. And then I'll do the same thing when I go to the left, except my numbers are getting smaller, so I will subtract 1.5. So I'll do 6.5 minus 1.5, that's going to give me 5. I'm going to subtract 1.5, that's going to give me 3.5. I'm going to subtract 1.5, and that's going to give me 2. And then I'm going to begin to look at the answers. It says, which group describes 16%? So that means you're going to be looking for these percents of the oarfish of the population. Select each correct answer. So this is a multi-select. We could have more than one answer. So if we go to the oarfish between 3.5 feet and 3.5 meters and 9.5 meters, that would be between here and here. That would include this area, this area, this area, and this area. So if we add all those up, that's going to be a lot more than 16%. So it's not the first one. The second one says oarfish that are shorter than 5 meters. So here's 5 meters. Shorter would mean anything to the left. So that means I'm going to add 13.6, 2.1, and 0.5. If I add those up, I get 15.8%, which would round up to be 16. Because remember, there's a little bit of the tail on this side that they don't count in these -3 to +3 standard deviations. So we're going to check this one. Oarfish that are larger than 8. So if we go over here and find 8, larger would be anything to the right. That would also be 13.6, 2.1, and 0.1. If we add those up, we get 15.8%, which would round up to be 16%. So that is true. All the oarfish that are longer than 8 meters would be 16% of the oarfish. And then the last one says, how about the oarfish between 6.5 and 9.5? That would be here. 6.5 and 9.5. That would be 34.1 plus 13.6. That would be a lot more than 16. So we will not check that last one. It all starts with labeling your x-axis here with your mean, adding your standard deviations when you go to the right, and subtracting your standard deviations when you go to the left, and then looking at the percents that are under the curve. Number 3 says the weights of bags of ready-to-eat salad are normally distributed with a mean of 290 and a standard deviation of 10. So my mean is 290. My standard deviation is 10. Always take 290 and go to where the z-score is 0. That's where the mean always goes. I'm adding 10 to the right, so that'll give me 300, 310, 320. I'm subtracting 10 when I go to the left. That'll give me 280, 270, 260. And then I read the question. What percent, so they're asking you for a percent of the bags, will weigh less than 280. So right here is 280. We're going to go less than 280. That would be to the left. And then we would add these 3 percentages up. We did that on the last problem. That gives us 58. And we would round up to 16%. So those first 2 problems are asking you to label your curve with the mean and the standard deviations to the right and the standard deviations to the left. And then find the percentages that match with the question. So number 1 and number 2 are both asking for percents. Number 3 is a little bit harder. It says the number of nails in a 5-pound box is normally distributed with a mean of 325. So we'll put the mean right in the middle with a z-score of 0. It says the standard deviations are 15. So we'll do 325 plus 15. That's going to give me 340. 340 plus 15 is going to give me 355. 355 plus 15 is going to give me 370. As I move to the left, I'll do 325 minus 15. That's going to give me 310. 310 minus 15, that's going to give me 295. And 295 minus 15 is going to give me 280. So it says, suppose there are 1,200 boxes in the warehouse. How many boxes contain more than 350? Excuse me, more than 340. So we go find 340. More is to the right. We've added this up. This is the 3rd time. This is going to give us 15.8%, which will round up to 16%. Now they're asking for boxes. That means we have to take the total boxes. We have to take 16%, and we have to change that to a decimal by moving the decimal 2 places to the left. And then we have to multiply the number of boxes by 0.16 to find 16%. 1,200 times 0.16 is 192 boxes. So this one was a little bit harder than number 1 and number 2 because number 1 and number 2 were both asking for just percents. And here we actually had to find the percent greater than 340, and then we had to multiply it by the total number of boxes once we changed that percent to a decimal. All right, I think this is our last one. Number 4 says, times for an ambulance to respond to a medical emergency in a certain town are normally distributed with a mean of 450 seconds. So by the time the ambulance drivers get the call and by the time they arrive at the scene, that's only 450 seconds. That's very quick. With a standard deviation of 50. So we're going to add 50 as we move to the right. We're going to subtract 50 as we move to the left. Suppose there are 160 emergencies in that town, and about how many emergencies are the response times between 400 and 500? So here's 400, here's 500. It's going to be these 2 percentages. So we'll add those up. 34.1 plus 34.1 is going to be 68.2. That's percent. If we take 68.2% and we remove that percent sign and move the decimal 2 places to the left, That means we're going to be multiplying 160 emergencies by 0.682. Got this little bar, I don't know if y'all can see it, but it's making me not be able to write. So that's going to be 160 times 0.682, and that's going to be about 109 emergencies. So we have to take an extra step for number 3. Emergencies. Trying to figure out how to spell that. Can't read my own writing. Alright, this is 6.08. I did have a small group today with my Tuesday group, and they felt really good about this section. Hopefully, if you were struggling with 6.08, this video will help you. If you have any questions, you can email me. I will be out of the office Wednesday and Thursday. I will try to answer my emails in the evenings. We are not usually allowed to have our computers during ACT testing, but I will try to answer your emails. So if y'all got questions, you can let me know. And if you use the whiteboard that I put in your email, make sure that you download it and you save it, and you can use it on your quizzes and your test. Hope you have a great day. Bye.